Concept zero is really pretty simple. If you have an oscillating system, like a kid on a swing or a mass on a spring or something like that, and if you provide a driving, if this is our driving frequency with the resonant frequency, okay, where they are equal, right, the system just goes crazy. Okay, so this dotted line here, this is an asymptote that approaches infinity. If there's no damping, if there's no dissipative forces, that is no way for the system to lose energy, and you constantly give it energy, then obviously it'll if you let it run long enough, it'll hit infinity, right? Take a long time to get there though, right? Okay, and then as you increase, as you add damping forces, right? Damping is just where you have a force that acts counter to the system, right? So if you've got a thing oscillating back and forth about an equilibrium, say it's moving this way, the damping force acts opposite the velocity, right? Typical damping forces are something like minus k times the velocity, and we'll talk about that later. That basically it's some constant times the velocity. It acts opposite the direction you're going, just like normal friction does, right? Notice that as we increase the damping, that the two things happen with this. Okay, the peak gets lower, right? So the peak moves down, and then the peak also shifts slightly to the left. This makes sense. This is frequency here that we're talking about, right? And so the frequency gets less, the period gets longer. If you imagine a spring trying to oscillate through thick stuff like water or something like that, it would take longer. And this is a small effect. For lightly damped objects, there's really no effect on the period. It's just when you start damping it a lot, okay? There we go. And then this is just, the resonant frequency is a factor of the springiness and the mass, okay, basically. This is another graph that just shows you this, and what it shows here is the damping factor, right? This is more and more damping, okay? And it shows that curve shifting to the left, like that. And then this is the envelope, is of course this infinity, right? But I think that's really all there is for concept zero.